So in this video, I want to talk a bit about some typical graph that you can find from the logarithm and the exponential. So here is our first graph. So this graph, we have the log x and the ln x. So the log x and the ln x, we have a graph that looks typically like this. So when it was smaller than 1, so let's say x is smaller than 1, then the log of x, or the natural logarithm of x, is actually smaller than 0. So when x is 1, the log of x is 0. Then as it increases, so as x get really big, so let's just say here if it was 10, and here it would be 1, right? So here would be 1. When it's get into very much to, let's say, 100, then here it's probably got to 2 already. So as the x increases, this slope also decreases. So a big increase in x can only result in a small increase in the y direction. So that is the property of the logarithm graph. Now let's get to the exponential graph. So here, let's just say this is 0. So when x is 0, we have a to the power of x is equal to 1, right? So here we have 1. But then if x is smaller than 0, then we have a to the power of x getting smaller and smaller than 1, but it never touches 0. Right? So remember, it's never touched 0. So as x increases, this increases much more rapidly. So here the slope actually increases through time. So then once we get very high, so a small change in x can result in a very, very big change in y. But here this is a exponential decay graph. So this is a to the power of minus x. So simply this is just only a reflected graph of this graph. So when x was very big, a very big negative number, a to the power of minus x is very big. But as it get to, so here's 1, x is 0, this is 1, x is bigger than 1, so a to the power of minus x get much smaller. So the property of this is called the exponential decay, and this is called the exponential growth. This is a relationship. So simply we have a to the power of x. So this is an exponential graph, and this is a natural logarithm graph. So these two is actually reflected through the, if you reflect one through the y equal x line, then you can actually get the other graph. So here, if you reflected a to the power of x, you get log the base a of x. This is also works for if here is e, and then this is this is l and f. This is also work that way. So that's some of the typical graph that might be useful when you imagine them in the exam.